Hello, algebra folks. Here is our next video in this contract, and it's 2-3, domain and range. And so we're going to learn all about what domain and range are. I know we mentioned it a little bit in the last video, but we've got a little bit more specifics to get into. And so just quickly, let's go through our notes and see what we can learn. First of all, domain is the set of all x values. And the range is the set of all y values. Okay, so we're looking for all the x's, all the y's, and all the different kind of formats. Now, there's such thing as a limited domain or range. It could be a limited domain or a limited range. And that is a domain or range that includes a, you guessed it, limited number of values, meaning there's only a few, okay, or such. And whenever we have a limited domain, we always write it in brackets. And these are brackets right here. They look a little bit like parentheses, but they're not. And I'll tell you a quick way to write a bracket. It's a loop, a V, and a loop. Or a loop, a V, and a loop. Okay? So that's what we need when we do brackets. We always put limited domains in those brackets. Okay? So you'll remember that when we talk about functions, we talked about lots of different ways to represent them. We have tables and mappings and ordered pairs and graphs, and we're going to throw in some other stuff here today. So I want to just kind of share with you all of the different ways we would find the domain and the range. Okay? So we're going to start with table. Writing the domain and the range. Remember that the domain in the table is all the x values, so we're going to put them in brackets. Typically, you put them in order numerically, but it really doesn't matter. So we've got -1, 0, 1, and 2, and then we close the brackets. And then the range would be just 3 and 4 because we don't put repeated numbers in the domain or the range. That's it for a table. Now let's look at the mapping. I'll have to scoot up just a little bit. You'll remember the mapping. The left oval is the x's, the right oval is the y, and we put f of x because that's function notation. So to find the domain, again, all the x values are -1, 0, and 3. The range values would be 3, 0, and 54. And you know I was supposed to put those in order. You could put 0 through 54. It really doesn't matter. It's just personal preference. So, but most of the time, if it's in a textbook or a test, you'll see them in order. Okay? And so now let's look at ordered pairs. We've got ordered pairs here, and it's going to be the same thing. We're looking for the x values and the y values. So with the domain, the x values are 2, 5, -3, and 5. So I'm going to put them in order, -3, 2, and 5. Because remember, we don't repeat or put repeated numbers. And then the range is -3, 4, and 7, and we put them in brackets. Okay? Now here's the next one. This is one we didn't really talk about when we talked about representation of functions, but you can also represent a function as an equation. Okay, we did function notation, but here's the equation. And in this equation, y equals 6x minus 3. You'll probably remember that from last year a little bit when graphing. The domain in this case, because it's an equation and there are no limits, then the domain is all real numbers. And you might see that as this R. Okay? Now in this case, since the domain is all real numbers and there's no limits, then the range is also all real numbers. Because whatever I plug in for x, I'm going to get a different y. They're not going to repeat. They're not going to be the same. You know, it's always going to be something different. So we would also identify it as all real numbers. Okay? So now we're going to look at a graph. Make sure you can see that. When we have a graph, Notice that this graph has a line on it. And I know it's a line because there's arrows on both ends. And those arrows means that that line goes on forever. I know it just comes off the graph a little bit, but in reality it goes on forever. And whenever you have a line that goes forever in both directions, that there's an arrow in both directions, the domain is all real numbers. And the range is also all real numbers. Because I can find an x and a y and an x and a y and an x and a y, and they would go on forever, even though you can't see it on here. Okay? It's infinite, doesn't ever stop. That means it's all real numbers. Now let's flip the page here, and you're going to turn your page over, and we've got some weird things going on over here on this page. Okay? So I have types of functions. Now there are three different types of functions that we're going to look at in algebra this year. Linear functions, which when graphed would create a line. We have exponential functions, and I'm going to go through these real quick and then we'll go back. Exponential function, and the graph of an exponential function is what we call a smooth curve. Now that curve could go this way, the curve could go that way. Could go this way, could go that way. Just a smooth curve. Okay? And we have what's called a quadratic function. A quadratic function, when it's functioned, forms a parabola. And a parabola is something that you might see when you go to the arches at the St. Louis Arch, also McDonald's. McDonald's arches, the two arches on the M, both of those are parabolas. We go up and then we turn around and come back down. Okay? It reaches one top point and then keeps going down. So those are the three types of functions. And to find the domain and range of those functions, we're always looking at the x values and the y values. So let's look here at this linear function. The linear function, notice it has a closed dot at one end and an open dot at the other end. That means that in this case we have a range for our domain and our range. That means there's a set number of numbers that are there. So we're going to start with the domain, and when we're looking at the domain, we're always looking at the x values going across. Okay? So the farthest x value on this side is -5. So I'm going to put a -5 right there. And the farthest number to the right is 8. So we know that all of these x values are between -5 and 8. And to write that as a domain, I'm going to put x in the middle. And we're going to write what we call a compound inequality. Okay, that's what happens when you have a set range of numbers that are your domain and your range. So we know that x is between -5 and 8. So we're going to kind of write this too. We know that x is greater or equal to -5 because there's a closed dot. But we know that x is less than 8. The reason it's just less than is because we have an open dot on 8 and 8 is not included. So this tells me that the domain falls between -5 and 8. So I will never have a point on this little line segment right here that starts with a -6 because it just is not included. It's from -5 to 8. So the -5 goes on the left, the 8 goes on the right, and the x goes in the middle. So now we're going to look at the range part of this. The range, and I'm going to use a different color on the range just because it's easier to see it. The range is going up and down. So we're looking on the y-axis to see what the highest number is and the lowest number is. So the highest number is 5 in this case because 5 is the highest number there. The lowest number is -3. So we know that our range is going to be between -3 and 5. And I'm going to write it just like I did the domain. So y goes in the middle because we're talking about the range. And we know that y is greater than -3. It's just greater because that's an open dot on the -3. But it's also less than or equal to 5. And this tells me that though all the values of the range going up and down start at 5 and go all the way down to -3, but don't go any farther. So this tells me that -3 to 5 is my range. The y comes in the middle, so I can read it two ways. Y is greater than -3, or y is less than or equal to 5. It's hard to get your brain wrapped around. That's why I'm using two colors on this for the domain and the range. So I'm going to go back to the red, and we're going to look at this exponential function, which is the smooth curve. Okay? The smooth curve. Now here's what you need to know about an exponential function. An exponential function, when it comes down to the x-axis, what happens with an exponential function, and we'll learn about more about these later, is it never touches this axis that it's going towards. Okay? So what's going to happen is it's going to go down right here, and it is never going to touch the x-axis. Okay? But it will go on forever up and go on forever sideways because there are arrows on both ends. So we're going to look at our domain. Because it goes on forever up and to the left, our domain is all real numbers. Okay? Because I can choose any x, and it's always going to be a part of that exponential function. The y values, though, the range, are going to be different. The range is going to start at the 0 on the y-axis and go up from 0. But it's never going to touch the 0 line because it just doesn't, and we'll talk more about that later. So the range for this is going to be y is greater than 0. It's not greater than or equal to, because it looks like it's going to touch, but what we know about exponential functions is it never touches that line. Now sometimes the curve would do like this, and then that means that it would be greater than or equal to 5. Sorry, not or equal to, but just greater than 5. And so we'll look at some different pictures of those as well. But in this case, remember that that bottom line that it's headed towards is never going to be touched. So that's why it's just greater than. Hopefully that's not too confusing. And I should have done that in blue. Oh. So now let's look at these parabolas. Okay, we got this parabola, and the parabola looks like an arch. And we're going to look at the domain and the range. Well, if we look at this parabola right here, I've got an open dot on 1, 5. But notice that the other side is an arrow that goes on forever. So if I'm looking at my domain, I'm looking at all the x values that go across. And it starts at 1 and continues to go higher than 1 forever and ever and ever. Because there's an arrow there, and that arrow means goes on forever and ever and ever and ever. So the domain for this one is going to be x is greater than 1 because that circle is open. If it was closed, it'd be greater than or equal to 1, but it's open. And now let's look at the range, and I will do this one in blue. The range is completely different. The range is starting at the very tip of the parabola. Where's that very tip? That tip is at 9. The highest point on the parabola is 9, and everything else is below the 9 because it goes on forever. It doesn't matter that this stopped here, but on this side it's going to continue to go on forever. So my range is going to be y is less than or equal to 9, because you can notice that that crosses 9, so it is included. That's why it's less than or equal to. The highest point on the parabola is 9, and everything else is below it. That's why the range is y is less than or equal to 9. And I've got this other portion of a parabola. Okay? In this portion of a parabola, again, we've got to look at the x values for the domain and the y values for the range. So what's the farthest x value? The farthest x value is -4. And I know that number is hard to see, but I'm going to put it right there. And the farthest x value on the right is the number 3. So because it's got 2 stopping points, I have a compound inequality just like this over here. So I'm going to put x in the middle. And we know that x is greater than -4, because there's an open dot, less than or equal to 3. Okay? So if we look at the range is not going to be a part of that open dot right there. The range is going to be right up here on what I think is, that's 2, 4, 6, 7. That's a 7 right there. And the lowest value is going to be -2, -4. Okay? So my range is going to be between -4, which is the lowest point of this half of or portion of a parabola, and 7 is my highest. So I'm going to put y in the middle, and we know that y is greater than or equal to -4. Notice I'm reading it backwards. And it's greater than or equal because there's a closed dot, but it's also less than or equal to 7 because 7 is a part of that parabola. So the highest is 7, the lowest is -4. They're both included because there are closed dots there, and so that's why the range is -4 to 7. I know sometimes it's hard to get your brain wrapped around the domain being left to right and the range being up and down, but we're going to continue to practice this so that we can find all of these domains and ranges easily. I hope you enjoyed this video. You get to see my face.